Hi, this is Ed from CNC Explorer. I've often tried to explain um, speed and speeds in terms of a ratio of RPM, chip load, and number of teeth. It's you can adjust any of the three terms as long as everything's in balance. You'll get an optimum cut. I was thinking about trying to explain this ratio of RPMs and chip loads and flutes in terms of gear ratios, and I found this gear generator. I'll put a link down below for this website. And it doesn't exactly do what I want as far as ratios and gear teeth, but I think we can go through it and explain how this is just interlocked. And you have to have everything match. You can turn up the RPMs, but your feed rates have to speed up, or vice versa. You can adjust the chip load, but that's basically set by the geometry of the bit you're trying to cut. So you can choose from any number of bits, of course. So let's go quickly through this representation of a chip load, a feed and speed calculation. So the highlighted gear, let's say, represents the spindle, and the units don't really matter, but we're turning at 10 RPMs, doesn't matter. It's a fixed rate. And there's another gear representing the number of teeth. Now, this only allows me to go to a minimum of 4 teeth, but that's okay because it represents the number of flutes on your bit. Then I have another gear representing the chip load. So for every tooth and every rotation of the bit, you take out so many inches of chip load. And so that gear now drives another gear, which is your feed rate gear. And that could be, let's say, represents your stepper motor, but it's equivalent of inches per minute, millimeters per inch, whichever unit you're in. So it's all interlocked. So if I go back to my spindle and I say, I want to turn this faster, let's say 50. Well, so that spins faster. I'm taking off more chip loads per minute because I'm driving my bits faster, and therefore I have to move my feed rate, how fast I cut into the material, faster. If I slow it down, then the opposite is true. I have to basically crawl. Now, this ratio is completely fixed upon my number of flutes and my chip load per tooth. So if I go back and say, I'm going to put this a little faster, go back to, let's say 25. All right. So my RPM is running at 25. And I'm going to increase my number of teeth well, let's say they double it. So instead of 4, I go up to 8. And you notice my RPM is still going at 25. But I had to increase my feed rate, in this case 7.49, because it's still a ratio. Everything, I've increased this ratio here of 1.38 to 1. If I go back down to 4, I have a 2.75 to 1 ratio. Well, if I, like I said, if I increase this ratio, I have to match it, as a gear would have to be matched to a faster feed rate. So I'm going to go back now to 4 for the number of teeth. And let's say this bit has a better design, and the chip load is higher on this bit. Now I represent that in this gear as number of teeth again, which really affects the diameter and the ratio. So as you can see, I'm increasing this ratio, and my feed rate has to increase to match it. Still going 25 RPMs on the spindle, but now I have to turn this gear faster so that my ratios match up. So I hope this explained that a little bit in terms of visual representation of the equation. And a lot of people, I don't know, they move one gear speed without adjusting another. And you can plainly see that if you did that, your gear train would be completely asynchronous. Instead, well, for lack of terms, stripping teeth, it wouldn't be a good situation. It has to be a ratio match. There's no way around it. This is the way the formula works. So I hope this, like I said, I hope this helped out a little bit. And we'll continue with these helpful videos as we develop them. Thank you very much. See you next time.